Alright guys, in this video we're going to be looking at calculating some equilibrium concentrations, and we'll also be looking at kind of how Q versus K works with that. In this first reaction, we've got N2O4 is at equilibrium with NO2. We got a Kp value at 70 degrees Celsius. A mixture of that is placed in a glass tube and it's allowed to reach equilibrium at 70 degrees Celsius. If the pressure of N2O4 is 1.33 atmospheres when the system is at equilibrium at 70 degrees Celsius, what is the pressure of NO2? So first thing I'm going to do is I'm going to set up my Kp, and that's going to be the pressure of my NO2, and that's going to be squared. Okay, I get that right here, my 2, because if there's a 2 in the front, it gets squared. And that will be the pressure of N2O4 on the bottom. Okay, now that that's set up, I can plug in the numbers that I know. So, for example, the Kp I know, that's 3. And I know the pressure of my N2O4, which is 1.33. So all I don't know is my pressure of NO2, which is exactly what I'm looking for. So I'll just solve for that. First thing I'm going to have to do is multiply both sides by 1.33. And that turns out, so the pressure of NO2 squared is equal to approximately 4. I rounded up, it was like 3.99, which is basically 4. And I do that because I can just take the square root of each side, and I find that my pressure of NO2 is 2 atmospheres, in fact. And there is an answer choice that fits that, and that is the answer. So this one really is setting up your equation, solving for the missing variable, and being able to find that. So this answer is 2 atmospheres. Okay, we'll look at another question. It's a similar but a little different. We got a reaction, and we're given a K value. At a certain point in time, a 1 liter rigid vessel contains 1.5 moles of PCl3, 1 mole of chlorine, and 2.5 moles of PCl5. Which of the following describes how the measured pressure in the vessel will change and why it will change the way as the reaction approaches the equilibrium at constant temperature? So first thing I'm going to do is I'm going to set up my Q value. Okay, oops, sorry, not heat. I want capital Q, reaction quotient. Remember, reaction quotient is set up the exact same way. The only difference is that this is solving for what it is right now to compare it to the K value. So I need the pressure of, or actually this is concentration of PCl5. Okay, it's a pressure, or it's a concentration because I have moles. And notice I have a 1 liter container. They like to do this in the AP test. That makes it really easy because then I can say that the PCl5 concentration is 2.5, the Cl2 concentration is 1, and the PCl3 concentration is 1.5. That's because its concentration is moles over liters, and since the liter is 1, you're just dividing by 1, so that makes it really nice. I'll go back to finishing my Q. It'll be Cl2 times PCl3's concentration. Okay. I just have to plug in those numbers. So on top, I'll get 2.5. On the bottom, I get 1. And I get 1.5. So ultimately, I'm going to be solving for this, and it's just going to be 2.5 divided by 1.5. And looking at my calculator, 2.5 divided by 1.5, I get approximately 1.66 repeating. Okay, definitely comparing my Q versus my K, Q is less than K. So right off the bat, I can say D is wrong, and I can say B is wrong. Okay, so just doing that part alone, I've narrowed it down to 2 answers, which is really nice in multiple choice. And on the AP test, and if you're running out of time right, if you can narrow it down to 2, now we're down to a 50-50, and that's always really nice. The next part we can start to reason with. Okay, if the Q is less than K, generically, okay, so what that means is we don't have enough products, right? Reactants turn into products. Whoops, sorry, products. And if the Q is less than K, we need to make more products. The Q value is too small, and the only way to make it bigger is by adding more products. That will increase the amount. So we are going from reactants to products. So these molecules need to turn into this particle, PCl5. So what is that going to do to the pressure? Well, we're going from 2 molecules as reactants, 2 molecules here of gas, to 1 molecule. And remember, pressure is a measure of how many molecules there are banging against the sides of that container. So if we're going from 2 molecules to 1, pressure should be decreasing, okay? So C is the right answer because the pressure will decrease because the Q is less than Kc. Q is less than Kc tells us that there needs to be more products. And since we're taking 2 reactant molecules turning into 1 product, we're going to have a lower pressure. So A is wrong. So this is the answer for C. So a little bit of thinking on this one. Once again, I showed you a way on how to narrow it down to 50-50, and then you'll have to use the rest of the reasoning to figure out the right answer.